again talk about how to find the equation of a tangent line, but in this case we have already like a given function or an equation, and we want to either find the or write the equation of the tangent line at one particular point, which is x equal to 1. So guys, we already know there's few things that one needs to actually write the or solve this problem. One is we need to know what is the equation of a line, or in this case it's going to be equation of a tangent line. So let us start by writing the first step, that the equation of a tangent line in this case, or the equation of any line, is y minus y1 equals to m, and here I like to write the subscript tangent, m tangent, because we are interested in the tangent line. And then on the right hand side I have x minus x1. This is also thought of as the point slope form. Why? Because it has the points and it has the slope, right? The other way of writing the equation of a line is the slope intercept, y equals to mx plus b. So guys, if you prefer using the slope intercept, it's totally fine. You can use that one as well. I usually like this form, so I like to use this form. Now, based on the given piece of information, let us see what we have and what we need to calculate in order to finally write the equation. Guys, we don't have the slope, but there's a way for us to find the slope. We know the slope of the tangent line is just the derivative of the particular function at that point. We have the function, we have the point, we should be able to find the derivative of this function, and when we substitute the value for x, we would be able to evaluate or find the slope of the tangent line. Right? Then the other thing we need is we need the point, and we already have the value for the x coordinate of that point, which is 1. We got to find the value for the y coordinate, and that is also not too difficult because I already have x equal to 1. If I substitute that x back into this equation, what I will get is the corresponding y value. So let us actually start with that. Let us start with evaluating the y1. So to evaluate the y1, what we have to do is we have to go back to the original function, which has already been provided to us, and substitute x equal to 0. So at x equal to 0, what happens? We've got to substitute x equal to, sorry, not 0, x equal to 1 in all of these. So guys, it's 1 cube. I will try to write all the steps here. So it's 1 cube plus 1 plus 1. That is for the first term, because you can already see that it's a product of two functions, right? And then there's the 3 times 1 square plus 2 times 1 and minus 1. Using the order of operations, guys, this is pretty simple. 1 plus 1 plus 1 is 3. And then this is, let's just simplify this. 1 square is 1. So 3 times 1 is 3. 3 plus 2 and minus 1. So it's just going to be 4, right? Because 2 minus 1 is 1. And then 3 plus 1 is 4. Guys, if I simplify this, it comes to 12. That means the point is 1 and 12. This is my x1, and this is the corresponding y value, which I can think of as x1 and y1 here. So I have my x1, y1. All I need now is to find the slope of that tangent line, and then we can write the equation of this tangent line. Guys, keep in mind, our goal is not just to find the derivative or the point, it is to write the equation of a tangent line. Sometimes I see students only finding the derivatives or just writing the point and not writing the whole complete equation. So guys, be careful, you have to write the whole equation. Now to find the slope of the tangent line, we know the slope of the tangent line is going to be just the derivative of the function, which you can write in the form d over dx of f of x, or which is the same as finding the derivative of this function f prime of x, but at what? At prime of x at x equal to 1, because we're interested at that particular point, x equal to 1. In order to do that, guys, our goal now is to find the derivative of this function. Again, one of the ways to finding the derivative of this function would be if you distribute this whole thing. So, but that would be a lot of work because this has 3 terms, this has 3 terms, and we would end up with a lot of terms. So guys, that is going to take us a lot of time. Can it be done? Yes, it can still be done by distributing everything, and then we'll have so many different pieces. Then you apply the power rule to each and every piece. It can still be done using that simple, straightforward method. But the other method we know is you can use the product rule, because now we have already introduced the product rule and we know how the product rule works. For the product rule to work, we consider one of these as f function and the other one as the g function, and then we set up the product rule. So guys, again, I have this habit of first writing the general rule and then I apply that particular rule on this example. So I'm going to remind you the product rule. It's the product of 2 and you take the derivative. It is f prime times g plus g prime times f. So keeping this rule in mind, then let us try to apply it to this particular example. Guys, I think I can squeeze in some of this here and then we can get rid of some of the other stuff and do the rest. So f prime is writing the derivative of this, not too difficult. There's 3 pieces, we got to do it piece by piece. So first one will be 3x squared. What am I using here? I'm just simply using the power rule. And then plus derivative of the x is just going to be 1, right? and we don't have to worry about plus 1 because derivative of any constant is 0, so that takes care of f prime. Then I just have to multiply by g, and g I just have to write it. I don't have to do anything with it except for I just have to write it, but I don't want to make any mistakes, so that's why I want to look at this carefully and just kind of copy and rewrite this. Guys, then I have a plus here according to the formula. Then I have to do the g prime, the derivative of this second function. The derivative of the second function should not be too complicated again. Everything is on the right in the x to the n power, and then we have a constant. So this would be 6x, because you just have to bring the 2 in the front, then 3 times 2 is 6, and you take away 1 from 2, it's just x. And then obviously the derivative of 2x will just be 2 because the derivative of x is 1, so 2 times 1 is just 2, and we don't have to worry about the negative 1 because the derivative of a constant is again what is just a 0. So guys, this we have to multiply this guy by, don't forget we have to multiply just by the f function, which is this function, x cubed plus x plus 1. So guys, this we were able to squeeze in the actual derivative of the function, but this is fine, we got to find that derivative, but we're interested in what? We're interested at point x equal to 1. So to find the actual slope, which is going to be like slope is going to be always a number, what we all have to do here is we have to substitute x equal to 1 in for all the values for x, and whatever we get is going to be the derivative of that function at x equal to 1, or in turn we can also think of that as the slope of the tangent line at x equal to 1. Okay, so let me get some space here. So maybe here we can squeeze it right here. So this is the derivative of f prime x, and now what I want f prime x, but x now at what, x equal to 1, which is we already know that is going to give me the slope of that tangent line, right? They are the same. Guys, I'm not going to try to distribute or do any of those things here. I'm just directly going to substitute 1 and then simplify. So when I substitute 1 here, it's going to be 1 square 1, 3 times 1 is 3, 3 plus 1 is 4. So it just becomes 4. This first parenthesis simply becomes 4. It's not too complicated for us to do that without even writing the whole step. Times, let us see what does this add up to. Guys, 1, 3 times 1. So let me do it on here, like it's 3 times 1 squared is 3 times 1 plus 2 times 1 minus 1. So 3 plus 2 is 5 minus 1 is 4. So this is still 4. Guys, if you want, like if you need to do it on the side, you can do it on the side. If you don't want to do everything in your heads, you can do just write everything out, substitute like 3 times 1 squared plus 1 and so on and so forth, and then simplify piece by piece. Again, if you're used to using a calculator, it's fine, but otherwise this is not so complicated. We can do it even without using a calculator. Then guys, plus, that takes care of the product of these two. Then this one, guys, is pretty simple. 6 times 1 is 6, 6 plus 2 is 8, so that's 8 right here. And then what do I have? Still have one more term. Well, I have to substitute x equal to 1, so it will still be 1 plus 1 plus 1, that would be 3. And guys, when I simplify this, 4 times 4 is 16, and then 8 times 3 is 24. We still got to add this, 6 plus 4 is 10, 2, 3, 40. So the slope of the tangent line at x equal to 1 is 40. We got everything what we need in order to write the equation of a line. Let us go ahead and actually write the equation. Guys, instead of m tangent, now I have the value for that. So we're going to substitute that with what, 40. And then x1 and y1. I have the value for x1, which is going to be 1. And I have the value for y1, which is positive 12. Guys, this right here is my equation in the point slope form, right? And if you like, if the problem says you want the final equation in the slope intercept form, then you know what to do. You just have to distribute this 40 here and then bring the 12 to the other side, and then you will have it in the y equals to mx plus b form. That's pretty simple, but you can also leave it like this. Most of the times if they don't ask us, like the textbooks don't ask us to get the equation in a certain form, it's up to us which form we want to leave it. So guys, there's nothing really so complicated about it, but I want to introduce this idea of finding the equation of a tangent line given different types of functions. We have already done an example where we just had to use the simple power rule and some other basic rules. In this case, yes, we still have to use the power rule. We have to probably keep on using power rule all the time, but before using the power rule, one has to use the product rule, which is going to make it easier for us to actually, or quicker for us to actually evaluate this or write the final answer for this problem. So guys, this was number 2, still the product rule. In my next few videos, I'm going to be talking about the quotient rule. Okay, till then guys, keep practicing and I will see you next time.